Section 5.2, Properties of Parabolas. In this section, we're going to talk about graphing quadratic functions and finding the maximum and minimum values of those quadratic functions. To graph a quadratic function, there's actually more than enough information from my equation specifically to graph my parabola. But one of the things that I want to do before I graph it is kind of get an idea of whether that shape is going to be opening upwards, so it looks kind of like a U, or if it's going to go down, so it looks like an upside down U, or sometimes people describe it as an umbrella, or whatever you want to do to remember that shape. Now, what I do to remember is if you read what it says about whether the graph opens up or down, is that says when a is greater than 0. Okay, well, what I remember is that numbers that are greater than 0 are positive numbers. So I like to think of it like this. If you have a positive person or a positive personality, you tend to be a person who smiles a lot. And so when you look at a parabola, I want you to think of a smiling person, right? So the parabola is opening upward. If you look at the second part, it says when a is less than 0, so that would be a negative number, and negative people tend to frown a lot. So I want you to think of a frowny face when you think of a parabola opening downward. So with a positive a, you're going to have an opening up, looks like a smile. And if you're going to have a negative a, then it's going to look like a frown. It's going to open down. Now, the other things that I can calculate about my graph are going to be some essential points for graphing. The first one is the axis of symmetry. And the axis of symmetry is a line where you have x equals the opposite of b over 2a. And the b and the a are numbers that come from my original equation. Same thing with the vertex. Once you find the axis of symmetry, then you can calculate the vertex. And the vertex is simply the x value that I calculated from my axis of symmetry, put that into my equation, and calculate the corresponding y. So in other words, I make an ordered pair out of that. And then lastly, the y-intercept is my c value, my constant. So wherever my constant is, that's where my y-intercept, and that's also going to be a critical point for graphing our parabola. Okay, so let's go ahead and look at how we can put these to use and actually calculate those items and graph our parabola. Okay, so before I get started here, I'm going to go ahead and on my graph, I'm going to draw my axes on here. So I'll draw my y-axis and my x-axis, and I'm simply going to use a scale of 1. So that'll make this a positive 5, and that'll make this a positive 5. Okay, like that. So my scale is going to be of 1s. All right, so let's take a look at what we know. Based on my equation, first of all, I probably want to identify what the a, the b, and the c value will be. Okay, so for this one, a, that's an ax squared, so a would be 1. B is going to be a negative 2, and C is going to be a negative 3. So whenever my formulas require A, B, and C, I'll use those 3 numbers. Okay, so we're going to start with, it says the axis of symmetry. So I need to find that first before I do anything else. So the axis of symmetry, remember the formula was the opposite of B over 2A. Okay, so for my problem, x is equal to the opposite of b. So when I talk about the opposite of negative 2, that's going to be a positive 2, divided by 2 times a, and a happens to be 1. So if I calculate this out, 2 divided by 2 is 1. So my axis of symmetry for my specific equation is x equals 1. Now, this isn't technically part of the graph, but it is something that's going to help me with this graph, so I'm going to draw that axis of symmetry as a dashed line down the middle, just to kind of give me a guide for my graph. Okay, so from there it says we need to find the vertex. Okay, so for the vertex, I was supposed to use my axis of symmetry and then calculate my y value to go along with it. So to do that, I take my equation, and I got 1 for x, so I'm going to substitute 1 in for x. So that makes 1 squared minus 2 times 1 minus 3. And if I calculate that out, that's going to be 1 minus 2 minus 3. So I'm going to end up with a negative 4 as my y value. So that makes my vertex the point 1, -4. Okay, so that's my vertex. Let's go put that on my graph. 1, -4 is my vertex down here. Now, if you go back and you look at our original equation, will my parabola from here go up or down? And if you look at your a value, your a was a +1. So remember, positive goes up. So I'll have a graph that's going up. Now, the last thing it says here is to find the y-intercept. Okay, so the y-intercept is located at 0, c. Now, in my case, c is a -3, so that makes my y-intercept 0, -3. So if I put that on the graph, 0, -3 goes here. Then remember from the previous section we did corresponding points. So the matching point on the opposite side of my axis of symmetry would be at 2, -3. And then I would use those to draw my parabola. Now, if I wanted my parabola to be a little more accurate, I could do, say, pick like -1, +3, put those into my equation and get some points to see where those are at. But what I'll do is just kind of as a guide, use my 3 points. It's not going to be perfect, but we're just sketching a graph here. So you get the basic idea of what this parabola would look like. Okay, so one last example that I want to show you is this where I have a quadratic equation and they talk about finding the highest point or a maximum or a minimum. Now on a parabola, you think about it, you've got 2 options, right? A parabola is either going to open up like this or down like this. So when I talk about a maximum and a minimum, I'm really talking about the vertex. And depending on the direction of the parabola, it's either a maximum or a minimum. Okay, so a maximum or a minimum, either way, is the vertex. And depending on the direction of that parabola, will decide whether it's a maximum or a minimum. If you look down here at the bottom, if it is opening up, my vertex is a minimum because that's the lowest point that graph will go to. If my parabola opens down, the vertex happens to be a maximum because that's the highest point my graph will go to. Okay, so what we're going to do here, they give me the equation, and I don't need a graph of it to tell whether it's going to go up or down. I just need to know what A is. Okay, so if you read through this equation, or through this problem, it says we have a projectile that's being fired straight up at an initial velocity of 64 feet per second. And it gives me this quadratic function, h equals 64t minus 16t squared. H is the height in feet, t is the time in seconds. And it says find the time the projectile needs to reach its highest point. Okay, now if I'm going to put it in standard form, it probably actually would look like this: negative 16t squared plus 64t. Okay, and that helps me a little bit figuring out my A and my B. But essentially what I want to know about this is, where is my maximum point, right? We're talking highest because so we're looking for a maximum most likely here. So essentially I'm just looking for the vertex of this parabola because this is a quadratic. So let's find that vertex, and to do that I start with the axis of symmetry. So I need to know A, which is negative 16, and B, which is 64. Okay, and in my case, oops, not H, I need to know T. Okay, that would be what I'm using as a variable here instead of X. So to do that, I'm going to end up with the opposite of B, so that's negative 64, divided by 2 times negative 16. And I'm going to calculate that. Negative 64 divided by negative 32 is a positive 2. Okay, so I'm going to have a positive 2 for my time. Okay, and really all it wanted to know is the time that this takes. So I'm going to say that my time is 2 seconds. Now, if it wants to know what is the highest point, then I'm going to take that 2 seconds and I'm going to plug that back into my equation. I'm going to get h equals negative 16 times 2 squared plus 64 times 2, and we're going to calculate that out. And I get a height of 64 feet for this problem. Okay, so yes, in my problem it simply asked me the time the projectile needs, so it was really looking for the 2 seconds, but if it also had asked me for the height, or if it had asked me for the height in the first place, then I would go with the 64 feet as my answer.